Hello guys, welcome to my YouTube channel. In this video, we will talk about one of the use cases project in machine learning, that is rock versus mine prediction using SONAR data. We will do all program in Python. We will be using Google Colab, which is a cloud-based system where you can write your Python script. So let's start. Consider a submarine. There is a war going on between two countries. So submarine of a country is going in underwater to another country, and the enemy country have planted some mines in the ocean. So mines are nothing but the explosives that explode when some object comes in contact with it. So there can also be a rocks in the ocean. So the submarine needs to predict whether it is crossing a mine or a rock. So our job is to make a system that can predict whether the object beneath the submarine is a mine or a rock. So how this is done? The submarine uses a sonar that sends sound signal and receives it back. So this signal is then processed to detect whether the object is a mine or it's just a rock in the ocean. So let's understand how we will do this. So the workflow for this project is like, first we need to collect the sonar data, and how this data is collected in a lab setup. So where an experiment can be done, where the sonar is used to send and receive the signal which bounce back from a metal cylinder and some rocks. So because mines will be made up of metals, so we collect this data, which is nothing but the sonar data, which we obtain from rock and a metal cylinder. We feed the sonar data to our machine learning model, and then our ML model can predict whether the object is made up of metal or it is just a rock. So this is the principle we are going to use in our prediction. So first we need to collect the data, sonar data. Then we will pre-process it, the data. We cannot use the data directly. So we need to pre-process it, process the data by various stages. Then we need to analyze the data. Once we pre-process the data, we will split it into training and test data. So why training and test data is done? So let's say there are 100 instances or 100 examples of the data. We will train over the machine learning model with 90 instances, and the rest 10 instances we will keep it for testing purposes. After splitting, we feed it into our machine learning model, because where we will use logistic regression for this purpose. In this case, we are going to use logistic regression model because logistic regression works very well for binary classification. This problem is binary classification problem because we are going to predict whether the object is a rock or a mine. So we will use logistic regression model, and this is a supervised learning algorithm. Once we train our machine learning model, we will be training with the training data, we will get a trained logistic regression model. So this model has learned from the data on how a metal cylinder will be and how the rock will be. So this model can recognize it based on sonar data. And now we give a new data, it can predict whether the object is just a rock or it is a mine. So this is the workflow we will follow. So let's start with coding. So as I said, we will be working on Google Colab. We will be coding on Google Colab. So this is the link you have to type on Google, colab.research.google.com. A page will like this will open, and just click on new notebook. So we will rename this as rock versus mine prediction. Once we rename it, then click on connect. So once it's connected, so we can start our coding. So first we will import the dependencies. Import pandas as PD from sklearn model. Import train test and split. Again, from we will import our logistic regression model. So from sklearn dot linear model import logistic regression. So we are importing numpy as np, and numpy is for array, and we are importing pandas as pd. So several data, it is used for several data pre-processing steps, basically loading our data into tables. So we use pandas library. So why we are using sklearn? Sklearn is very good Python library for machine learning algorithm. So again, for we have imported our logistic regression model. So we will also import our accuracy check from sklearn dot matrix for accuracy score. So with this, the accuracy score is used to find accuracy of our model. So we will shift and enter, then it will run this cell. So our dependency are already imported. So we will start with data collection and data processing step. So, and before that, we will load our data. So you can see this file folder. Just click on it, and here we have to upload the data. So just click on upload, right click and upload. So this is the SONAR data. Click on OK. So here is the data we uploaded. Just click on these three dots and keep the copy path option. So now we will load the data set in pandas data frame. SONAR underscore data pd dot read underscore csv and We will paste that path we have copied. And header equal to none. So shift enter. So why this header equal to none? Actually, in our data set, we don't have any header in our data set. So header equal to none. So let's see our data set. So this head command will, as you know, that it prints the first 5 rows of a data frame. So you can see there is no header in our data set. So we have kept header equal to none. So here is the data set. So you can see that there are actually 61 columns. The 60 we have data till 59th here. So actually it's starting from 0. So 60 columns are used for examples. 60 columns are our features, and 61th column, that is this column, is our label column. So there are a lot of numbers. So we can just see our data set in real. So you can see there are actually 61 columns, a lot of numbers, and almost 208 data points. You can see there are 208 data points. In last column, we have R and M. R indicates M indicates mine, and R indicates the rock. So this value is obtained in the lab setup, where sonar data is collected from a metal cylinder. And for a rock, as you can see, there are several features, and the feature represents the column of the data set. We feed the data set to our machine learning model, and it can learn on how a rock can be and how a mine can be. So let's close this data set. So we will continue our coding part. So we will see the exact number of data set and as well as column. So we can type sonar underscore data dot shape. So this will give the number of rows and columns. So we have 208 rows of examples of data and 61 column. 61st column tells us whether it's a rock or mine. Now we will do some statistical measures on our data. So sonar data dot describe. So you can see, and this is the statistical measure of our data. So like 50% means percentile means 50% of the data is less than this value 0.0288 for the first column. So 75, similarly 75 percentile means 75% of data is less than this value. So you can see the count as well as mean and the standard deviation. So let's see how many examples are there for rocks and how many are there for mine. So we will sonar data 60 dot value, that's called counts. So if you remember that we have 61 column but the 61st column is our label column. So we will not include that, and we will include only the feature column. So you can see there are 111 instances of mine and 97 instances of rock. So there are almost equal mine and rock. So our prediction won't be a biased one. For better model, we will be requiring more example and more data sets. Here we have just 268, I guess, 208 number of instances. So for preparing a better model, you need to have like some thousands or lakhs of data set. So we will proceed now. Then again, sonar underscore data dot so here you can see that we have taken out the mean of every column. So for mines as well as rock. So and there is a quite, we can see that there is a quite difference between the mine and rock, which will help for our prediction purposes. So now we will separate the data and our levels. So in X, we will store our sonar underscore drop X is equal to 1 for Y, sonar underscore data 60. So the here we are separating the data in the label column. So X will contain the feature column and Y will contain the label column. So we will drop in feature column. The only 61st row, column was our label column. So we'll drop that column, and in Y we will store that 61st column. So here it is. So we will drop the last column. If I am dropping a column, then axis is equal to 1. For dropping a row, then axis is equal to 0 should be written. So we will perform this. Sonar data, sorry. Data dot drop, sorry. So we have separated our data and label column. So we will now print and the feature column as well as the label column. So print X and print Y. You can see the label column as well as the sorry, you can see the label column as well as the feature column. So now we will start training and testing our data. So as we have an equal number of rock and mine in the training and test data, so means like quite a similar number of rock, not almost, it's almost equal in numbers. So we will start to train our model. X train, test, Y train, Y test is equal to train underscore text underscore split pass x, y, and our test size equal to 0.1. Then t5 equal to y, random state equal to 1. So why we are using random state equal to 1? To like to split it in a particular order. So why we are using stratify, we need to split the data based on rock and mine. Means like equal number of instances will be taken, so there would not be any biased data taken on either test and trained for training purposes or as well as the testing purposes. So these will run this. So we are using this test size of 0.1. Only the 10% of the data is used for testing, and the rest 90% of the data will be used for training purposes. So now we'll print the shape. Test.shape. So here you can see the original data set of our feature column, and here is our training features, and this is 21 is for testing purposes. 187 feature will be used for training purposes, and the 21 feature will be used for the testing purposes. So we will see the training and the test level, training and the test data set. So print so this is the X train and this is the Y train. So now we will start our model training using logistic regression. So we will call model equal to logistic regression. So we have created a logistic regression model. Then we will start training the logistic regression model with the training data. So model dot fit training data set is X train, comma Y train label. So you can see logistic regression model has been applied on our training data. So we will proceed for model evaluation. After training means like we have to see the accuracy of the training data. So we will proceed with that X underscore train underscore prediction. Model dot predict. Training underscore data. Accuracy the accuracy score. Prediction and y train. So we will compare our model with the original prediction of the data. So let's see. So now we will print the accuracy on the training data. So we'll run this. So you can see that the accuracy on the training data is almost 83%, which is actually good. Something anything more than 70% is considered to be good. So now let's see our accuracy on the test data. So we'll copy this. So training, we will convert it to test. X test prediction and Y test. So this is the test data accuracy we are calculating. So all done. We'll execute it, shift enter. Then we will print our test data accuracy, just like we have printed our training data accuracy. So we'll copy that ratio on test data. Test data accuracy and shift enter. So you can see that our accuracy on test data is 76%. So which is pretty good. So now we will make a predictive system. So by like giving input, giving input in a raw format. So let's do a make a predictive system. So input underscore data. So let's see our data. So you can see this data. So we will take one row. So we will open this in Notepad. So we will take this instance. So you can see here it is predicting that it's a rock. So we'll copy this and we'll paste this. So we will remove that R column. Now enter. So this we will change the input data to a NumPy array. So input underscore data underscore as underscore NumPy array. So np dot as array input data. So now we will reshape it. So reshape the NP array as we are predicting for one instances. So we will reshape it, input data input data as numpy dot reshape 1 comma -1. So there is only one instance and we will use it for prediction. So we have reshape it to 1 comma -1. So prediction equal to model dot predict our input reshape data. So print the prediction. Okay. Then we'll put a if condition. So to if it is a rock, so it will write and this is a rock. The object is a rock. The object is a mine. So for that we have to write a if condition prediction print. If it is R, then print it's a the object is a rock. Else print we'll copy this that is mine. Mine. We'll run this. So we remember that input which we have taken was a rock only. So the object is a rock. So you can cross check that this input we had taken and this was a rock. So it correctly predicted as a rock. So that's for this and that's it from my side. Hope you enjoyed this video. Thank you.